Okay, so hi everyone, nice to see you all. We're used to having about half the people who sign up for free webinars coming, so we've had 50 people sign up and we've got 22 here, so I think that's a good number. Thanks for coming. Nice to see you all. We're really excited about this webinar today because we had a webinar in November about ontologies, which was led by Yuri, who's also here. And we asked people at the webinar, would you like to know about using ontologies to create knowledge graphs? And like everybody said yes. 100% of the people, and it was about 50 people, said yes. So we decided to do this webinar. For those of you who don't know me, my name's Sarah Barber. I co-lead IEA Wind Task 43. And also, well, my main job is to lead the wind energy division at the Eastern Switzerland University of Applied Sciences, which is in a little town called Rapperswil, which some of you have been to, which is very nice, close to Zurich in Switzerland. Before I start, I'm just going to do my normal slide. Those of you who know me, we at IEA Task 43 like to foster an open and inclusive culture. So we try to use gender-sensitive language, we try to use non-violent communication, and we try to practice active listening. If anyone wants to use this slide or get access to it, then you can on the website of the Diversity Committee of the European Academy of Wind Energy. And now to the agenda. So I'm going to probably spend the next 5 minutes just quickly telling you about IEA Wind Task 43 and also about the previous webinar that I mentioned. And then the main part of the day of the event is Arco, who is hopefully going to be here and working soon, who is from the Knowledge Graph Alliance, and I'm sure he'll tell you more about that. But it's an alliance we got to know a while ago who focus on promoting and learning about knowledge graphs. And so we're really happy to have an expert to come to talk to us and give us some demonstration examples. And after that, we have another talk from Joyjit Chatterjee, who is also here and smiling away. And he's one of the few people that we know about who's directly applied knowledge graphs to decision support in wind turbines. So we're really excited to sort of see a very 15-minute presentation about some of his work. He will be also talking at an internal IEA Task 43 monthly meeting soon, and he will be speaking at the annual general meeting of Task 43 in June. So you'll be able to, if you like what he's talking about, he'll talk about it more at those two events as well. And after that, I've left a decent amount of time for a discussion and Mentimeter questionnaire because we're really keen to get your inputs about how you use ontologies and knowledge graphs so that we can work more effectively in the future. In Task 43. If anyone's got any questions, feel free to just put your hand up on the chat or just interrupt me. Oh, that's fine as well. So I'll just keep going. So IEA Wind Task 43 is part of this thing called IEA Wind Technology Collaboration Program, which is an international collaboration trying to bring together, align research in different areas of wind energy. And Task 43 is about digitalization. So we're trying to unlock the full value of wind energy through digital transformation. And we want to act as a digital transformation catalyst. We want to drive open collaboration. We want to deliver insights, recommendations, standards, and tools in these three areas of data, culture, and competition. These three areas come from a paper that we wrote a couple of years ago called The Grand Challenges in the Digitalization of Wind Energy. It's a very long, detailed paper, but the main conclusion is that we need to focus on these three areas. So data means basically how do we structure data to make it usable for analysis or scalable for AI systems. Culture is how do we develop an organizational culture which promotes and enables digitalization, because at the end of the day, it's about people using digital tools. And competition is not it's not a mistake. It's a combination out of competition and cooperation. And it means things like how do we learn together, be innovative together across different organizations. So using things like challenges, competitions, learning from each other, user groups, stuff like that. So Task 43 is structured into these three working groups who focus on these topics. We also have a fourth working group who looks at use cases, and we have a management working group who tries to get inputs from the industry and academia and also disseminate it. So this is kind of what we're trying to do today. Some of the things we do, we developed a wind resource assessment data model. We've developed an ontology publishing portal called Technoportal. We're developing some different types of best practices, and we've written some review papers. So to the last webinar, I've just copied some slides from Yuri. Just quickly, we talked about what are ontologies. So ontologies are information models in a form of a directed labeled graph where we have different nodes with concepts or instances, and we have edges which represent properties and relationships. And so that's an example of a very simple ontology where we would describe a wind turbine is a product and it has a certification and it's a certain model. I'm just going over this quickly because I've already almost got to the end of my time in the time plan. And other terms that get used for ontology are things like information model, taxonomy, control vocabulary, semantic artifact, schema. And here we're showing a rough illustration of what we call semantic gradient. So it's like the complexity of the relationships that are described in the semantic artifacts. So you have things like glossaries, which are just lists of words and they're defined. To going on to control vocabularies, where these things are really defined in some controlled way, to taxonomies, which show hierarchies, and then we have ontologies, which actually show these different relationships. So you can use ontologies for metadata if you want to make your data fair, which means findable, accessible, interoperable, and reusable. You can use it for validating and verifying data, and then you can use them as a foundation for knowledge bases or knowledge graphs, which is the topic of today. These can then be used for expert systems, which Georgia is going to talk about afterwards, and then for hybrid AI systems and grounded LLMs. You can read more about it in the paper. I don't know whether, Yuri, you want to put this, if you've got able to put the link to this paper in the chat so people can read more about what we've done. The Technoportal is a portal that we released recently, which allows you to publish ontologies, which means that people can look at them, but it also means that they're available in machine readable format so they can be queried by tools that you be analytics tools that you use. So maybe you can also put the link to that in, but that's the Technoportal. That's what we talked about in the last webinar, like how do you publish ontologies in this Technoportal. We recently launched a group on the We Do Wind ecosystem, which is a community of people sharing data. And we launched a group called the Information Modeling Community, where we have different groups developing different ontologies. We're actually trying to develop a wind energy domain ontology. So if anyone's interested in joining that, I'll put the link in the chat in a minute as well. We're trying to provide a platform for the industry to co-create ontologies rather than everybody doing it separately and not talking to each other about it. So quickly to come to the end, some of you filled out a survey when you registered, but I've actually forgot to turn it on. I made a mistake, so I actually only got the last 13 people. And so this is the type of people who are signed up for this webinar today. So 55% from research. We also got, just from the last 13. So this is probably biased, but most of you didn't attend our previous webinar in November. Most of you rate your experience of using knowledge graphs as very low. And most of you rate the potential of knowledge graphs as very high. The one is a high on here, but then not all of you. So we want to correct that, hopefully, today. And some questions about using knowledge graphs in the future. There's some of the answers. So some of you want to know that today. Some of you think it could be revolutionary. Some of you are not sure. But we're going to ask these questions again anyway in the Mentimeter at the end. So now I'm going to pass on to Arco. Are you available now? Arco, is your...
I think
you
so.
Yes, we can hear you.
My microphone is working.
Yes.
Okay.
We can see you. Does anybody have any questions about what I said while Arco's just getting his screen set up?
So testing again. can you all hear me? There is no echo. I am using a strange setup with my phone and as well as my laptop. So just checking if you can hear me well.
We
Hope
can.
so.
I'd say the quality is not that great, but we can hear you. I think maybe if you just make sure to speak clearly, it should probably be okay.
Let's see.
Maybe just keep going and then we'll see how it goes.
Yeah, okay. So how about now? Okay. I'll try to speak louder. So sharing my screen, and thank you, sir, for the introduction. You gave such a nice summary of what we are going to speak. I'm afraid now that if I can add anything extra in my 45 minutes, but I'll try. Okay. So also the survey is really helpful. This is an introduction to the knowledge graph or knowledge engineering as such. I mean, of course, it's a vast subject, but I'll try to cover from the basics to the advanced topics. But of course, I mean, as I am doing a huge coverage, I'll take giant leaps and kind of do a 10,000 feet topological survey of the field. Like, so please do not expect that, okay, you will really get to know the algorithm methods and the steps of performing things in the tools. But of course, it will give you all the pointers where you can go and then look for more information. So I'm Orko Paul Sarkar, call me Orko, that's what everybody calls me. I am a researcher at National Institute of Standards and Technology in USA currently, and I am working in ontology and knowledge graph for almost 15 years, I believe. But my PhD was in industrial and systems engineering, so I focus mainly on industrial systems, business applications, etc., where I use ontology and knowledge graph. Um, so starting with the agent, okay, so I'll keep it like really flowing. So introduce the knowledge graph, the basics of it. Maybe, I mean, some of you already know all of that, but I'll go to the knowledge engineering. I mean, topic is kind of give you the map of what is out there. And then I'll go to what do I mean by semantics of knowledge graph, where I introduce the ontology basically. And then I will talk about some of these KG building methods. How can you generate KG? And then I'll show some of the application or talk about the state of the art where knowledge graph is being used. I mean, Sarah already mentioned some of them. So what is KG? So basically, KG is a new way. I mean, it's not new. I mean, anymore. I mean, I mean, I mean, anymore is there over 30 years, but then it's a new way of representing data using a graph structure. So what is graph? Graph is basically a collection of node and edges. But when we use this graph structure for representing data, we 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 use the node to denote different entities in the reality. I mean, person, car, any transaction, whatever. And the edges kind of denote the relationship between them. So important point to note that this is kind of like a labeled, directed, and multi-graph. So labeled means that all the nodes and the relations have some label. It is directed graph. That means it's unidirectional kind of edges, and then multi-graph. That means that two nodes can have multiple edges with different labels. Also, knowledge graph admits what they call properties. So you can add key value pair like in both node and also relation. So it's kind of like easy to visualize, and it comes really handy in like many different activities in the knowledge engineering to understand that how this traditional flat system of representing data, which kind of is very prevalent for the RDBMS system, but also you can think of simple spreadsheet or a CSV file, right? So that is the flat data. But then you can see that when we kind of transform the flat data into a knowledge graph, how we do that is that every row kind of become an entity in that graph, and it creates relationship with the values of that corresponding values for different columns, right? So the columns kind of indicate the properties. I mean, that those are the relation, with that particular instance. But one thing you can notice that when you represent your data in a flat structure, you kind of duplicate data. For example, you can see in this example that both of these turbines are in the same wind farm, but you have to repeat it. But in the case of knowledge graph, going back here, you can see you are mentioning the wind farm just only once with the relation with two different turbines. So this is the difference between a flat and a graph data. But then also, when we represent data like that, I mean, we can also think about creating the model of the data, right? So, I mean, a starting point of understanding what we mean by model, to think that all of these nodes may be grouped under their common, grouped according to their common properties or relationship. And those groups, then we can label. That label, you can think like if you are already familiar with the type and class, then this label kind of the label of the type and class. So then, of course, these class nodes, which are simply classes, they can be also related with different ages. However, then the interpretation becomes different. And then this type of graph where only classes and are related among each other, that is only the relationship between grouping, maybe that is the step towards understanding what ontology is. But we will talk about that in a couple of slides later when we introduce the ontology format. There's also, I want to mention that there are different kinds of graph used in knowledge engineering. So there is a special type of graph used in some application called property graph, where along with these, every node and every edge can have key value pair, as I said, earlier. But some other graph do not allow that. So when you represent that, then of course, the next logical step is you need to query, you need to access the data. So of course, knowledge graph can be queried, and exactly like SQL used for flat data, there are different query language for knowledge graph. Here is an example of a query language called Cypher, which is used in the Neo4j graph database, and then it's extremely popular solution for knowledge graph. And you can see that the same example I have represented in the Neo4j. So the knowledge graph is in the Neo4j, and I can query the knowledge graph to get different data. When you represent the data in a graph, of course, like then you can apply different graph algorithm to analyze and then find some implicit information. Of course, this slide will be shared. And I have put some hidden slide where I have put some instruction and command which you can try later in Neo4j or somewhere else. Okay, so that being said, this is just the introduction of what knowledge graph is. I want to show you this map. And this I call like kind of like, it's not the 100% or not an exhaustive list, but still it kind of captures the picture where what are the different activities that involving knowledge graph, right? So for sure that we need to create the knowledge graph, and we need to create a knowledge graph from different data sources. The data sources can be structured, for example, RDB system, Excel, CSV, XML, UML, CSML, many different formats, JSON structure, like, okay, many different structure format, can be unstructured also, text, book, blog post, emails, everything. Also, it can be multimodal. So you can include image, you can include, audio, video, etc. So to generate the knowledge graph, there are several methods. And then I'll mention some of them. I have listed them here. Basically, how do you extract knowledge? How do you clean up the knowledge? How you validate that, okay, your knowledge graph is consistent? How do you transform the model? All of this. Now, once your knowledge graph is there, of course, you can do some other things. For example, you can fuse different knowledge graphs together. You can modularize version knowledge graph, like to maintain the update and other things. And also you can transform that knowledge graph for different application, right? There comes also this ontology and taxonomy, which kind of organize the knowledge, and we'll talk about that. And also reasoning and inference. That means that whatever data you got from the sources, you can actually find some extra information from that existing data. And that process we call reasoning and inference. And I'll talk about some tools. And what are the application of knowledge? Where can you use it? You can, of course, you can use it for KG query answering. Of course, I showed some very simple example, but this can go really complex to generate answer from a knowledge graph. Of course, it's heavily used in KG-based recommender systems. For product recommendation, all other recommendation for search, different kinds of search. KG is used in machine learning, deep learning, KG, and LLM is growing popular. The traditional use of knowledge graph and ontology, however, to enable intra and cross-domain interoperability. And also there are some new uses, for example, explainable AI and the fairness of data, as Sarah mentioned. So now let's jump into what we mean by ontology. So I have to explain it in this way. So you can see that there is some unstructured data, sentence probably, maybe it's some reminder or email. Some reminder or email. You can notice, you can observe that a sentence like that is very easy for human to understand. You can clearly understand that it is talking about two people meeting on a certain date at a certain location. But then computer cannot understand that. It's very hard for computer to understand this sentence. Okay, now we can represent it in a knowledge graph, as I showed. Yes, you gave it some structure, it has some syntax, but then still it does not have the semantics. So what we mean by semantic is the meaning. So it's kind of like what we really mean by this different node, in terms of their character, their category, and other things. So of course, computer can understand it more than a unstructured, just a simple English sentence. But the real understanding comes when you lay a semantic layer on top of the knowledge graph. So of course, like it's not very different. It kind of like goes in the knowledge graph itself, very much compatible. It's not anything extra. I mean, it's like completely integrated. But what we mean is that this layer defines how the data is organized in the knowledge graph. So it helps in evaluating the consistency of the knowledge graph. Also, you can perform reasoning to find new information. So this semantic, now, of course, this layer of semantic, what I was mentioning, and I was hinting at that in the previous slide, that this is like a link. I mean, it's a graph of these different groups, or what we call class or type. Ontology is a field where we try to define those groups formally. And when we try to define those groups, we take help from a very classical subject called philosophy, as well as linguistics. So this is the formal definition. So the thing is that whatever uh, um, whatever uh, so what ontology does is that, as I was saying, this like network of groups, that graph of groups, right? These classes, then we label with a shared vocabulary, right? So ontology provides, first of all, a shared vocabulary, and then we provide a formal definition. So it is not exactly a natural language definition, but it's written in a formal language, mainly logic, right? So that kind of gives you the constraint on like how these different the entities under those classes are related to each other. The to achieve that shared property, I mean, that this is where the various principles from the philosophy and linguistic come into the picture, right? But of course, this is also been adopted by the W3C in the light of the semantic wave. I'm not going into the great promise of semantic wave of Tim Berners-Lee and etc. You already know about that. But at this point, I do not know whether the dream of semantic wave was successful or not, but it really built up a framework where various tools and languages were developed, which provides a lot of support for knowledge engineering and then using graphs and ontology. So some of these we will talk about. One thing is that the building blocks of the ontology are these terminologies. So the terms are these labels to these classes, also can be labels to the relation, right? So here we can see that that what we mean by classes is that there are different objects which are of the same characteristics, then you can group them under a class. And then here you can see that then you can relate one class to another class. For example, that agent class is a subclass of human, but then sometimes agent class can be subclass of software also, as like in a sense of AI agent or software agent. And then you can say that, okay, every agent needs to work at somewhere, or and at least it should work at one organization. There cannot be any agent not doing anything. So you can also say that in the ontology, or as part of the definition of the agent, that agent is something. Something means agent should be a human or an software, and there should be an organization where this agent works, at least one organization, right? Now, I already say that you can write this type of constraint, right? Like there are several different types of constraint you can write. You can mix those constraints together, but we need a formal grammar to do that, right? I mean, otherwise we cannot really harmonize them, and so it will be difficult to write algorithm or procedure, around them. So this grammar is provided by logic, and there are different logic used in ontology, from first order logic to higher order logic. But W3C proposed or developed this language called web ontology language, which is extremely popular, and this is built on a language called description logic, which is a subset of the full first order logic. By doing so that making it a subset of first order logic with only some chosen construct under a constraint, it becomes really fast. Whereas first order logic is really expressive, but it is not, the algorithms are not that efficient for first order logic, but for DL, they are really efficient. But also it assumes these different best practices, for example, unique name assumption, open world assumption, which also is very helpful. But I'm not going into the detail of what they are. We can talk about that later. Okay. So also another part is that ontology modularization. So the ontologies are not monolithic. As I was saying, that we are trying to, the goal of ontologies is to provide that shared vocabulary. But for a particular application, the shared vocabularies, need to be defined based on more generalized terms, right? And so in this part of generalization, if we can stack different types of ontology of different generalization, we get something like this, which is very popularly known as the ontology, modularized ontology stack, where there is a very broad and domain independent and only with some general concepts sit at the top, which are called upper level ontology, mid level ontology, but then more specific concepts which are particular to your application, particular to your domain, sits at the bottom, where there are these domain ontologies and use case ontology. One example is the industrial ontology foundry being developed under a top level ontology called BFO, which is an ISO standard, ISO 2138. Now, finding domain ontologies for sure is a challenge, and some domains are not that developed. Some domains are heavily developed, so there are many alternative ontologies. So finding ontologies for your domain starts from looking into different portal lookup services. This is an report I edited in 2022, I believe, where we have listed some of the standard ontologies used in business and industry. So now jumping into how to build KG, Sarah, would you remind me how long I have?
You're supposed to stop at 5 to 5. So you've got 18 minutes left.
Okay, excellent. Okay. Okay, let's see, because I wanted to focus a little bit on that. I believe that this is part or one of the focus of this session is to how to generate KG. So here are some of the, some overview. So majorly, knowledge graphs, the I think the interest of using knowledge graph or generating knowledge graph is from unstructured data, because 80% of the enterprise data are unstructured and there is no good solution for that. And this is the promise that knowledge graph provides, that you can model unstructured data, right? And so the first thing comes in the picture, or the or you can say these were the first, or like first methods people use are all the methods from NLP, right? But then when structured data comes into the picture, you already have a model, but it's not an ontology model, or it's not in the knowledge graph. So we do not really call it like how, the methods are not similar. For structured data, is mostly data transformation, schema mapping, or semantic enrichment, stuff like that. So I will talk about that a little bit overviewing. So some of these NLP techniques are used to extract knowledge from unstructured data. I can take an example. This sentence called "the solar plant was built in Seville by two companies." And then there are different methods. For example, part of speech tagging, kind of tag different word or like phrases. And then you can extract the named entity, for example, the solar plant, the location name Seville, the company names. You can also create the dependency among different phrases or word. And then there is something called open information extraction, where you can actually extract triples from the sentences. And once you extract the triple, it's really easy to put it in a knowledge graph. Well, sounds easy, but in practice, for a large knowledge graph creation from unstructured data, often resulting an ambiguous, incomplete, and inconsistent knowledge graph. I've given some example why it is so. Basically, when in unstructured data, we try to use different terms and different words for expressing the same things. Sometimes also we use the same term to express different things. This creates the ambiguity. Not all relations are captured, so that makes it incomplete. And then sometimes it makes inconsistent assertion or connection. For example, it can have like, oh, this one of these turbine is at two different locations, but then it's not possible, right? So definitely something went wrong. So then the area of knowledge graph construction deals with kind of correcting the knowledge graph. It tries to extract relation, entity, link those entities in a proper way, try to disambiguate or deduplicate those entities. And there are several methods, and then mostly from learning and or like some type of probabilistic logic. I'm not going into a detail, but some of the tools for these corresponding methods are mentioned, so you can take a look. Now, for structured data, of course, as I say, that the method is a little bit different, but that it follows a typical ETL process where you extract the data by API, SQL, XQuery, and then map the schema. There is Sparkle, but there are also other tools. In the table, you can see for specific types of document, there are tools available. So they are like custom tools specific for that type of document. Then you can create custom pipeline following a typical ETL steps. Now, very importantly, I want to mention this, and this, of course, heavily talked about in the community. There is, of course, two different direction of how knowledge graph is used, or also that created two different ecosystems. However, that is not a division. I mean, sometimes they also come together, but there is these two different ecosystem. One is a graph-based, a pure graph-based, and there is this logic-based. So the pure graph-based are like property graph, label attributed graph. Sometimes RTF graph is also used. But the logic-based heavily focus on this ontology, OWL, RTF, and then also different types of logic, right? Description logic, first order logic, and there are different, notation, for example, cliff notation for first order logic. The focus for graph-based is the graph structure so that it can be traversed easily, and then we can apply graph-based algorithms. But on the logic-based, the focus is on using logic-based theorem prover and reasoning services. Graph-based are really fast, but they are less rigorous and also less expressive. And then logic-based are extremely rigorous, but then of course there is a steep learning curve, and then it is also a little bit slower. I mean, contextual. Yeah. So the use is different. The use of graph-based is, say you want to create some knowledge graph from different data and you want to do some analysis, but you want to forget about it. And then for that, it is, of course, the graph-based solutions are good. The logic-based solutions are where you want to achieve persistent storage, you want to check conformance of your data, you want to exchange that data, achieve cross-organization, inter-organizational integration. One thing is that if you probably do not need ontology, if you are thinking to use it in a project which will be only for your team, if there is no cross-department, cross-organization, cross-project, interaction with the data, probably you do not need ontology. This is like my rule of thumb, kind of. Okay, so now I'll end by showing you some of these applications of, ontology and knowledge engineering. For example, the traditional use is that ontology helps in mapping data from source to target. And then it actually based on logical theories, and then once you match the ontologies of source ontology to target ontology, there are tools which kind of make the pipeline of the data, and then the data is automatically transformed. Here is one example of like this type of data integration is being used in a project called Excel Lab, which we are doing for last 3 years, where we are integrating different types of models. Here models, I mean, say system design model, say AutoCAD model or simulation model, like that. Sarah already mentioned ontology and fairness. I just want to mention that ontology is the eye of the fairness. It's not my statement. It is from Gizzardi. But ontology is really important for interoperability. And as like Technoportals showed, we also deployed another OntoPortal instance for industrial ontology called Industry Portal. So the KG and LLM is now becoming really popular. There are several tools where you can use the KG as a for creating rack pipeline using LangChain. You can use LLM to generate query for your knowledge graph, and then several other things. Then, of course, KG has been used in and continuously being used in ML and DL. So, I will say that it is also a testament that sometimes people kind of differentiate these two different methods of the artificial intelligence, but they are not very different. They come together theoretically. also in practice. And you can see some of the example and also some of the tools used. Now, I mean, of course, we are going further, and there are some niche application where knowledge engineering comes into the picture, and they are being tried. And some of this publication we have worked on recently, that knowledge engineering can be used for explaining complex models, and also knowledge engineering can be used to capture this common sense knowledge. Is a highly controversial and ephemeral type of knowledge, which is kind of comes into hand to capture the background knowledge or the expert knowledge for a domain. And then, of course, like it is used in decision making in uncertain situation. For example, flexible manufacturing, finding your resource, etc. So I will finish here, and I will, if there is any time, I can answer question. But,
yeah, perfect. Thank you very much for that really nice overview of different tools. I think some of us have learned about new tools and the connection between ontologies and knowledge graphs, and especially then on LLMs, which is obviously a topic which lots of people are talking about. Does anyone have any questions? Yuri's made a comment which we might want to read. Well, Yuri's put his hand up, so maybe he's going to say something. Go on, Yuri.
The comment I wrote just before we got to the slide with LLM, so I felt a bit silly making it, and you just got No, actually, the question I wanted to ask is on the slide with structured data and data transformation techniques. One of the things we in our community have been struggling with is kind of taking the best of the both worlds, one world of semantic web technologies and logic-based approaches to representing data and graphs, and the other one is the world of JSON schema validators and JSON schema way of describing the requirements on data, let's say, or structuring it. Have you come across some research or some publications on the topic which kind of discuss this idea? Because we've seen that it's the advantages of just the ease of explaining like something like JSON schema to people are quite high, and also it is used with modern APIs quite a lot. But it's not immediately clear to us how do we kind of like connect it to the world of JSON LD and Shackle and these validators, and how do we make these two kind of like how do we take the data that has been structured or the models that have been created in JSON schema and bring it into the world of knowledge graphs?
Yeah, this is a good question. I mean, for sure that you already mentioned JSON LG. So JSON is, of course, natively compatible with W3C technologies. You can encode an ontology or knowledge graph in JSON LD. So of course, you can then use it as a response for your API. You can send the response in a JSON LD, and there are certain there are some tools which kind of use let you do that really easily on top of the traditional Spring framework. This fits really well. However, the challenge comes when I know that some of the organizations, they publish standards in JSON, and it can be API standard, that can be some data model, I will say that one example, for example, the asset administration shell is written in JSON. But then they claim that this is ontology also. So I will say that we should not get hung up on like this definition of what is ontology exactly. If you have a JSON model, you can really use it to store your data in any graph DB. I mean, in Neo4j or graph database, that is not a problem. But then you want to also model it in some rigorous ontology. If it is your goal that you want to model it with that, you want to keep it with JSON so that you can exchange data or like provide API responses, you can keep that, but at the same time, you can create another layer where it is also modeled with some rigorous ontology standard, if that's your goal. But completely depends on your requirement. As I said, if you do not need that rigorousness of ontology, maybe you do not need the ontology layer. But you can definitely use the JSON structure to model your data in a property graph without being too rigorous. Does that answer the question a little bit? But if you provide some more context,
I completely agree with you that, and that is actually partially where the question arose, is that sometimes we don't need that semantic expressiveness of like a full rigorous ontology or some logic rules and things like that, or definitions of classes. But there are some things that are available through knowledge graphs that and in JSON LDs that are not available in classic JSON and JSON schema. One example would be linking to like control vocabularies, which is quite difficult to do in JSON schema. It's not very elegant, not very nice. So I guess my point is, are there any like good discussion on this topic, specifically like JSON schema and JSON LD? Maybe there isn't, and we are the first ones to bring it as a discussion. And if you're aware of any like such discussion or papers or books, I would be happy.
I cannot remember that the name of the tool, but it is there, which is kind of like let you create APIs which deal with only JSON LD, not JSON. But also, it is not very difficult to convert a standard JSON into JSON LD. You just need to insert the context. That's all. But yeah, but of course, as you say, the research, I want to mention one thing, that the research is, of course, in semantic web, that you said that logic and ontology you do not need. I want to differentiate between this ontology and the logic part, right? The logic part is heavily used in even say just knowledge graph without ontology, right? Less rigorous knowledge graph, let's say that, or property graph. It's heavily used in logic. You can create rule to check, you can create probabilistic rule, and I mean, I mentioned some of that. So the logic part is not exactly ontology. Then now the ontology uses the logic to provide the rigorous definition. That is something else, right? So the research is, of course, I mean, even when you are talking about just JSON LD, I mean, people try to use it for different types of logic, but at the same time for training. So the neurosymbolic or like whatever, like those things comes into the picture. Even there also, it's not even if you don't use ontology as such.
I think we're out of time. But we're out of time. So I asked Jordan to talk at 5 to, which is, so I think we could let him talk now. And if there's more questions or discussion, we have, after Jordan's talk, we have and then we'll do the Mentimeter, and then we've probably got 10, 15 minutes to talk further anyway, if that's okay. Arco, will you be able to stay until the end? Or?
Yeah, I'm staying.
All right.
Thank you
Great.
so much. Yeah.
Thank you very much, and thanks again. And again, if any questions come up in the next few minutes, then feel free to write something in the chat, and if we have time, we'll get back to more questions after the next presentation. So, George, are you ready to take over?
Oh, yeah, sure. Let me share the screen. Can you see the screen?
Yes.
All right.
Yeah.
Okay. So hello again, everyone, and yeah, thanks for the invitation, Sarah. And yeah, so I think you have had quite a nice overview of knowledge graphs in detail in the last presentation, right? So that was, I think, really an excellent summary of how knowledge graphs are built and how you could actually leverage them like in a domain agnostic way, regardless of what industry you are in. You could use it in variety of ways. So what I'm going to talk about is like a little bit more aligned to like how you could use knowledge graphs in conjunction with AI models for explainable decision support. So I'll give a quick intro about myself and context about what this or where this is coming from, right? So currently I'm a lead data scientist at EPAM Systems, which is an American IT consulting company that provides like, AI product development for Fortune 500 companies and lot of those. Previously, I was with Reckitt Benckiser for several years. I worked with the R&D and supply chain teams in using AI for sustainable manufacturing, how we can reduce wastes in factories and stuff like that. So like I have had an interest and passion in sustainability uh, for a while. Before that, so this research actually comes from my PhD when I like worked with explainable AI, leveraging SCADA data from wind turbines for, like decision support for operations and maintenance and stuff like that. So it actually comes from that time when I thought that, okay, like, yeah, that, yeah, can we actually use knowledge graphs? Like I'm no expert in knowledge graphs, and neither, like it wasn't something that I have done previously. So it was more like a experiment, a proof of concept that can we actually do something with knowledge graphs at all by integrating it with SCADA data, and can we get like intelligent decision support from AI models. So that was the thought process behind that. And yeah, so I'm going to cover a bit about how kind of I worked through my journey, maybe starting from scratch with no background at all in knowledge graphs. What did I do to get there, and how I tried to build this POC and actually use knowledge graphs to build like a question answering system. So that's the summary of the presentation. So challenges in operations and maintenance, right? So I mean, we all know that the uptake of wind energy has been growing rapidly over the years, but with that, the complexity in O&M that has also gone up significantly. And according to some papers, it can like actually contribute to around 30% of the total cost of using wind energy. So O&M costs are quite significant, and a lot of work has been done in the last 5-6 years at least in using like AI models, both like traditional machine learning and over the years, like, deep learning models, LSTMs, and all of that for like predictive decision support, for time series forecasting of like power curves and stuff like that in wind turbine. And of course, as you know, AI with all that nice SCADA features from various sensors, it's really powerful. Like you have so much data from so many sensors, you can actually use that to train models that can predict faults in different subcomponents and things like that. But as you know, most of the like newer AI models, or like especially the bigger ones, more complex ones like the neural networks, they are often black box models. So we can't trust the decisions behind these models, or often it's quite hard to get like like you can't use, for example, an LLM off the shelf which is trained on internet data and ask it to make predictions of O&M actions for the wind industry, right? So like in a safety critical industry, that's quite challenging, and this limits the uptake of AI overall in the wind industry because you can't trust the models, you can't use that for intelligent question answering, to build a chatbot maybe for the engineers and technicians and stuff like that. So that's why the lack of explainability indirectly or directly it contributes to the challenges in uptake of data science and AI. And decision support, it needs to be human intelligible and actionable, right? So we are predicting a fault, but that's not of much value until we can say that, okay, how do we actually go in and fix or avoid that fault? Like, how do we make sure that fault doesn't happen in the first place, and what are the best actions I could take as an engineer to prevent such a like a catastrophic scenario, for example. So this is the overall framework which we proposed, that we can use SCADA data from a real world wind turbine. So in this we use the data from the Leeuwenmouth demonstration turbine, like which is a turbine for R&D that the ORE catapult in the UK operates. So that's the SCADA data you have there. Then you can train a AI model with all the logs of historical faults and alarms and the SCADA features to, actually make predictions about what faults are happening and things like that. Interestingly, as you know, a lot of the AI models these days, you can get feature importances, and that can help you understand why the model is actually predicting what it is predicting. So with those feature importances, you could actually then use some sort of a knowledge graph, which I'm going to talk through, and you can actually get like more insightful decisions. So by leveraging those explainable AI models plus the feature importances that you get through it, you can actually extract the relevant insights, novel insights, decision support mechanisms from the knowledge graph itself, and several use cases, which could include like explainable anomaly prediction, interactive graph exploration, and of course, querying and reasoning O&M actions, right? So that's multiple things that could be done with it. So understanding knowledge graphs, as you see, like in the wind industry specifically, you would have something very similar to like you saw in the previous presentation. So you can have like the different nodes, you will have different connections between these nodes, which will tell you different things. So you can see, like, for example, this is a graph with 3 distinct nodes, 2 edges, and 3 labels, which is defining an alarm in the pitch system. So if you see here, there is a particular alarm in the wind turbine, the pitch heartbeat error that affects the pitch system. And this pitch system is actually a type of a functional group in the wind turbine, which is basically like the different subcomponents. So you have pitch system, generator, and stuff like that. So based on that, you can actually build that analogy. You can add in properties, which would be very information rich, right? So you can actually add in things like even images and stuff like that. So even you can add in images of how the pitch system uh, error might look like in real world, how a particular type of fault might influence the wind turbine and stuff like that. So a lot of things could be added. Values could be added, like the specific ranges of SCADA values or features in which you might actually trigger some sort of an alarm or anomaly. So variety of thresholds, descriptions, and yeah, all those things could be added to your knowledge graph. So that is what kind of I tried to create, as you will see from manual. So very much there was nothing when I was looking at it like three years ago or something. I didn't find any like available resource online or anything like that. So I then came across this Skillwind project, which seemed to have like a technical description manual of a couple hundred pages that the authors had worked on, which showed you like how you could train engineers and technicians. Like it was kind of a training manual for engineers and technicians in the wind industry. And then I reached out to some of the authors and said that, yeah, can I do like a POC, build a knowledge graph out of this technical description manual, and like use it to integrate it with AI models. So that was like the beginning and like the start of the journey in actually building this from scratch. And as you would have heard and seen, right, that the wind industry currently, there isn't much practical demonstration of use cases of O&M or decision support with knowledge graph. So we are at a very embryonic, like very early stage in this respects, and it's very difficult even if you build a knowledge graph, like given sometimes the complexity of querying them, interacting with them. There has been like over the years, it has been quite challenging to actually interact with them. But luckily, now we have LLMs, now we have more intelligent ways of like conversing with AI models conversing with knowledge graphs. So I think that's like a great time, like no better time than right now to, actually start working on building domain specific knowledge graphs. So our solution, it was something we called XAI for Wind. So explainable AI for Wind knowledge graph. It has got like 537 nodes and 1059 relationships across 9 types. It's multimodal, so it has got, like the numerical data. Like, so I combined it with SCADA features. I added in images wherever possible, semantic relationships between those systems or subsystems, and it was built in Neo4j with your Cypher language, right? For Cypher graph query and declarative language for interactive querying and interactive reasoning with your knowledge graph. So here you can see a very quick example. Like, you have a turbine called study turbine that is rated power of 7 megawatt. It's an offshore wind turbine. Location is Leavenmouth. So just example of kind of the properties you could assign to the node. And the study turbine, it can contain multiple subsystems. So as you see, it has got like several things like blades, converter, plug brake, and power cabinet and things like that. And then with that knowledge graph, you could even, like build sort of more comprehensive relationships. So it was something that at that time there was no LLMs, like I say, so it had to be done pretty much manually, maybe in a semi-automated way, but most of it was manual effort to build this kind of knowledge graph. And you can see that, like there is an error in the yaw system which affects the yaw system, and that is affected by something else like the twist sensor fail or things like that. And what would be the corrective action, what would be the preventive action. So you can create different kinds of nodes and associate them with different kinds of relationships. These days it's much more, I think, like, it's much more democratized in creating knowledge graphs. Like, recently Anthropic released the MCP, right, the model context protocol, in which it's basically like enabling you to connect to different data sources including unstructured data, and you can connect it to like an LLM like Claude. And you can actually ask it to create knowledge graphs just by doing some clever prompt engineering. So you can actually simplify the whole process of writing like 1,000 Cypher queries into maybe just doing a little bit of prompt engineering in combination with a human in the loop. And it can really bring down the time to actually do these things. And of course, I think what we really need is for experts, right? So like me being from the AI domain, and not being a domain expert of like the how the wind turbine system is organized and things like that. I think what we need is more people who are SMEs to come up and actually create these kind of systems and interact more closely with the AI community. And that's, I think, where the magic can happen, like the most value can come. So how the knowledge graph enables decision support, as you can see with Cypher queries. Of course, you can query like preventive actions for like a generator. So you can see, like, you will see several nodes that are associated with the exact actions you need to take for preventive maintenance on the generator of the wind turbine. You can map the SCADA anomalies to faults, as you will see in the next slide. And it, of course, makes the O&M accessible to non-technical users, because Neo4j provides like certain things like Neo4j Bloom, which is like a natural language platform for interacting with your knowledge graph, right? So here you can see this is Neo4j Bloom, and I can just go in there, I can type in preventive actions for blades, and it will show me all of the kind of associated nodes or properties with those nodes. And same I can do for any other type of like anomaly in the SCADA features. So on the right screenshot, you see like different SCADA features, and I can query it for different kind of actions that I need to take for tackling those scenarios. Combining knowledge graphs with AI models. So this is like where it could be really powerful, like knowledge graphs. So you have some sort of AI model like XGBoost, which is used for anomaly prediction. You can predict the faults in like 14 different classes. So you can see from that graph on the right, upper right, like we are predicting the faults in 14 different classes. And these are like the top SCADA features that are contributing to the different kinds of faults. So with that, what we can actually do is we can map those feature importances to the knowledge graph in itself. We can map it to, okay, that, yeah, I am predicting a fault in the pitch system. This feature is the most important, that is highly likely leading to that fault. And then just based on that, I can get, like the right actions like pull up the right actions from the knowledge graph and query it accordingly. So it can actually help you bridge the gap between black box AI with like more explainable, transparent insights that will come not from the LLM or not from the AI model, but right away from the knowledge graph itself, which will be crafted by a domain expert and that can be trusted more so than an LLM, for example. Uh, you can see that you can query it with natural language questions. So what we try to do is actually build this scenario that whenever you have natural language questions, you can have like an AI model such as a transformer, which will generate the cipher queries for you. So instead of using the AI model to generate the answers directly, which can be untrustworthy at times, the model might hallucinate, as you might have seen with ChatGPT and things, right? So instead of just generating the answer, I'm asking it to generate the right query, which will be used to pull up the right answer from the knowledge graph. So you can see the cipher queries are generated with that AI model, and based on those cipher queries, I can then get the right insights from the knowledge graph for any kind of anomaly, any issues I see in the like power curve of wind turbine and those kind of scenarios. So that is like just a quick glimpse, like how you could use a transformer model for question answering, and like you could use it to go from SCADA features into like maintenance actions, like a full comprehensive decision. um, yeah, again, a very quick example, right? You see questions on the table, you can convert it to cipher queries that will fetch the answers, and you can see different kinds of answers retrieved from the knowledge graph on what are the right ways to fix or avoid that fault. So that can be pretty handy. Um, Insightful visualizations you can get on different kinds of faults. People might want to see that, and it can help them to actually, like see it more visually rather than just like plain text, which can get like boring and which can be like time consuming to work with. So this is very insightful. And finally, yeah, so to summarize it all, with this kind of a knowledge graph, you can enable like real-time decision support, interaction with explainable AI models. You can use like different algorithms, graph data science techniques, algorithms to, do some sort of analytics or intelligent decision making on your knowledge graph. And I think the future is where the SMEs work on building the knowledge graphs with the AI community together, and that will actually help in instilling unified industry standards and open data sharing. So that is, I think, where we can actually bring most value. And with that, so you might want to look into the two papers, right? So the XAI for wind, that is one of the paper that goes into detail of our journey in creating this knowledge graph for the wind industry, and the second one is like the application, how you could use that knowledge graph for question answering and yeah, like build a chatbot for the wind industry. So with that, thank you very much for your time and attention.
Great, thank you very much for lots and lots of information in a very short amount of time. That's very inspirational, and I'm really happy that you've done all this work with using a guideline for skills in wind energy. It's very interesting way of learning about wind energy as well. I want to do the Mentimeter quiz. I see that Chris, have you still got your hand up, or you put it down?
No, it was by mistake. I just wanted to clap.
By mistake.
I wanted to react and clap, and I clicked on the wrong button.
Okay, I'm going to ask you to do the Mentimeter thing first, because it's one of the things that we need to do we want to use the results to write a report about our annual report for Task 43. So I want to do that first, and then after that, let's have any questions that come up. So if we do this quickly, we should have time. So I've put in the chat. Let me just share my screen as well, because then you can also use the QR code if you prefer to do it on your phones. So you can either just click on the link in the chat, or you can, as soon as the screen's sharing, you can scan the QR code with your phone. Just do that quickly, because then I can share the results with everyone. So the first question I'm just asking, I see 10 people have done it so far, and we've got 24 people here, so I'm going to wait a little bit until everyone's got it. So I'm going to take away the QR code. If you still want to access it, just use the link in the chat. So the first question is, did you attend the previous webinar? So yeah, we can see the answer. It's not very interesting for everyone else, but actually it isn't interesting for us because everybody at that webinar said that they want to learn about knowledge graphs. And so the expectation would be that everybody would have come, which they didn't. So that's interesting. So the next question is, you've got to answer these 5 questions. So how do you rate your own experience of ontologies and knowledge graphs? Creating ontologies, using ontologies, creating a knowledge graph and using knowledge graphs. So I think you can just use a slider or put a number. So if your experience is low, you go to the left, and if it's high, you go to the right. And I can see the distribution as you go along, so it's quite interesting. This is obviously after the presentation, so you probably rate your own experience a little bit higher than you would have done before, maybe. Now you've attended this. But okay, so we have the highest experience of knowledge graphs and ontologies, but actually creating them is lower, and then using them is even lower, and they're quite similar with knowledge graphs, so it's changing slightly. So we've generally got quite a low level of everything here, which was kind of to be expected. Okay, and then an important question. So I think there's 2 more questions, this one and another. How high do you rate the potential of knowledge graphs for wind energy? It's also correct answer, everybody. Brilliant. Everyone thinks it's got a high potential, but no one's got experience in it yet, which is where I see chance for Task 43 to contribute, hopefully, through learning and working together on projects like Joyjit's project, for example. So we've got a very high value there. And then I wanted to know, how likely are you to use or co-create ontologies in the next year, 5 years, 10 years? I think the next question is the same, but for knowledge graphs. So this is just for the ontology part. So yeah, so I expected that to be higher with time. So in 10 years, there doesn't seem to be a big difference between 5 years and 10 years, but there's quite a difference between 1 year and 5 years. So probably we all see our, the next year as continuing as is, and the next over 5 years, hopefully we'll learn and then use some of this stuff in real work. So that's also very interesting. And then the same question for using knowledge graphs. So we definitely have a similar pattern. But I think we have a lower score. If I go back to can I go back to the previous one? So the previous one, we've got 3.14 and 4. Although I don't understand why there's scores. I guess it's not the mean, but the median. And 3.14 and 4. And here we have 2.73. So generally it's lower, but the development with time is the same. And then final question. How do you think knowledge graphs will be used in wind energy in the future? So I think we've got a word cloud here. You just put some keywords in, like O&M or whatever. The O&M is one I can think of. Decision making, predictive maintenance. Does anyone think it could be used for wind farm planning as well? Like, we've got loads of stuff about the operational phase. Okay, grid and load balancing is probably one as well. Fair data, control software. So that's all very, very, either very general data related or insights related, or operationally focused. So yeah, I wonder if there's something to do with also planning and wind resource assessment, wake effects, or Yeah, the whole thing of downscaling large scale wind resources that might come in there as well. But who knows? Generative AI and wind, monitoring, system monitoring. Okay, very good. Thanks. Oh no, there's even another question. Sorry, I thought it was the last question, but it's not. Which topics should we address at future IEA Wind Task 43 webinars? So what we've had so far, we've had one on culture, we've had one on digital twin common architectures, we've had one on ontologies, we've had one on data users working group, and we've had this one. So what comes next for everybody in a logical step? What should we talk about next? Use case demonstrations, yeah, that's kind of the next logical step. Also ontology development, wind energy domain ontology, yes. So I mentioned, well, Christian mentioned, and I put the link in, that we're trying to develop a domain ontology, knowledge graph, technology stack, yeah, LLM, privacy and security, explainable AI. Quite difficult to read these when they all keep moving. Transfer learning. Yeah, Chris, you wanted to say something?
Yeah, just Georgette, thanks for the interesting presentation. And I thought it was very encouraging that you said that an important part is for the domain experts to kind of to create ontologies to formally encode the knowledge in the domain. And I think that's something we're very keen to do within IEA Wind Task 43. And we have actually started a small group talking about creating an ontology around SCADA data. So it'd be interesting perhaps to connect at some point if you're interested.
Sure, yeah, of course.
I put the link, by the way, to that group in the chat before. And the other thing is I've applied for a little bit of funding to push that group on a little bit. So let's see if we get that. Okay. You can feel free to keep adding as you have ideas, but let's move on to, we've got 5 minutes left. So does anyone want to ask Georgette a question? Another question?
Yeah, just following on from some of the discussions there just now, do you have a feel for how much effort is involved in setting up ontologies or knowledge graphs and maintaining them over time? Is it a big effort or a reasonable effort?
Yeah, that's a good question. Setting up, I would say maybe 2 years ago, it would have been like really, like a Herculean task, honestly, like especially when we are building it for such a domain, like a complex engineering system like wind turbines, which can have several intricacies and granularities. But now I think with the help of LLMs, with the human in the loop, with techniques like reinforcement learning, which you can use to actually take feedback from the humans and improve your knowledge base over time and things like that, I think it's yeah, it's like not that much effort. It's still effort, like in terms of like having the experts in the room who will be able to understand that, okay, this is being created correctly, like what are the different components of the knowledge graph that actually like it's making sense, this is not making sense, and things like that. Maintenance, I think, would be like, yeah, like based on time, like if you have some different kind of like you are integrating it with different subsystems, if you are having like new sensors incorporated in the wind turbine, then you can easily update it with time, right? So you can easily include like new nodes or new relationships and properties, and you can build on what is already there. So I think getting started building the first foundations is the most time consuming part, and then scaling it up, it's like fairly decent like work.
Very good.
Yeah, thanks for that. It's a very, very relevant topic. I see Jason. Hello, nice to see you. Good morning. Hope you're well. Do you want to ask your question?
Yeah.
Bearing in mind we've got 3 minutes left.
Sure. So maybe you can compare and contrast the kind of older expert systems thinking. So that was really codifying, engineering knowledge and other kinds of knowledge into systems. So compare and contrast, that way of thinking with maybe what's different today with knowledge graphs, with data, with ontologies, and what's really changed.
Yeah, that's a nice question again. So yeah, I would say that historically, from most of the papers I have seen, for example, in the ML word, traditional ML that was used, like they were using signal processing, vibration, sense analysis and stuff like that for predictive maintenance and things like that. And what the decision was mostly like, okay, I could get a confusion matrix at the end that I'm classifying faults with so much accuracy, that is my F1 score. And that was pretty much most of it for the most part. In traditional expert systems, like you say, there was no natural language. I think what we were really missing is, like that human interaction bit where you can actually get that natural language summaries, where you can actually read through something, you can understand why a model is predicting what fault is occurring, like actually from an AI model, right? Not just from like a rule-based engine in which we could traditionally like use threshold and we could just say that, okay, yeah, this is the limits and outside of the spec limits there is a fault. But yeah, now with AI, I think that like more recent models, natural language generation, it has become, I think, much more feasible, much more possible. So we can actually build like those interactive question answering systems which can connect to your traditional expert systems that can actually help you to get like nice summaries for SMEs on different types of scenarios in the wind turbine. You can actually get, like multimodal. You can actually, I think, put in images. You can club the images with natural language, and you can actually try to, like predict things based on images. You can actually get summaries out of it in text. And I think that human interaction bit that was missing in traditional systems with LLMs and Gen AI plus knowledge graphs for the trust component, it has become much more doable now.
Awesome. Thank you.
Thank you.
Okay, it's exactly 5:30. Let's just stop. I know, Yuri, you had your hand up before. I don't know, like, I think we should, you're shaking your head. Okay, let's stop here. I think that was really great. And thanks for all of you for sticking around for the 1.5 hours. I think it was really useful. I'm glad to start this journey about ontologies, knowledge graphs, and AI. If you're interested about this, to hear more about this topic, we are going to be discussing it at our annual general meeting, which is it's going to be happening in Golden, Colorado in the US, and it's also going to be online if you can't make it. So I'll put the link in here if you want to hear Georgette talk more, and Yuri talk about an application of it's. We've got quite a focus on the second day on generative AI. Otherwise, if you're not a member of Task 43, I'll put the link on the website to join. And if you want to work with us and see what we're doing, please have a look at the website. And if you've got any questions, then please let me know. I will email you all in the near future. I'm on holiday next week, so I might not manage it until the week after, with a link to the recording and the slides. Georgette and Arco, if you could send me the slides as well, that would be great. And then, yeah, keep in touch. Thanks for everyone for coming and listening and talking, and see you all soon.
Cheers. Thank you very much.
Thank you very much.
Thank you. Bye.